All right, so consider the following equation. X squared plus y squared equals 1. So it's a circle. And suppose, so here's a point in the circle. The point in the circle is something like 1/2 square root of 3 divided by 2. So it's possible over here to draw a tangent line. But I want to find its exact slope. So my question is, if x squared plus y squared is 1, what is the derivative of y with respect to x if x is 1/2 and y is the square root of 3 over 2? And so we're going to figure this out using something called implicit differentiation. So here's the idea. Suppose that some function g of x equaled x squared plus f of x squared, and I wanted to find g prime of x. So the derivative of g would be, well, the derivative of x squared is 2x, and the derivative of f of x squared, you use the chain rule. So you bring the 2 down, so you get 2 times f of x to the first times f prime of x, right? And now notice that here what I'm saying is g of x is equal to x squared plus f of x squared, but g of x also equals 1. So that means g prime is also equal to, where's my thingy, sorry, g prime of x is also equal to 0. So what I get out of this is that actually (2x plus 2 times f of x times f prime of x equals 0. So the usual way I would write this is I'll say 2x plus 2y times y prime equals 0. All right, so I'm interested in what y prime is. Well, so what I can get is I get that 2y times y prime is 2x, and so then I get y prime is 2x over 2y. Actually, that should be negative 2x, right, because I subtracted 2x from both sides. And so I get negative 2x over 2y, which is negative x over y. So putting everything together, at the point 1/2 root 3 over 2, negative x over y equals negative 1/2 over root 3 over 2, which is negative 1 over the square root of 3. So what I'm saying is the slope of that line is negative 1 over the square root of 3. And it goes through the point 1/2 root 3 over 2. So the equation of the line should be something like y equals negative 1 over root 3 times x minus 1/2 plus the square root of 3 over 2. And let's go over here and actually type that and see what happens. Y equals fraction 8. There you go. There's your tangent line. So typically when we do this, I'm not going to do it with the explicit redefining of y as f of x. So let's try a different one. I made up a new function here, and my function is x times y squared plus x cubed plus y equals 0, and I want to find y prime. So what I'm going to do is I'm going to do this using implicit differentiation. And the way I'm going to do that is I'm going to just take the derivative of both sides of this equation. So my question is, I'm going to take the derivative with respect to x of x times y squared plus x cubed plus y, and that's going to equal the derivative with respect to x of 0. Well, this is just 0, so that's boring. This is the interesting part. Okay, so I have x times y squared. So in order to take the derivative of x times y squared, I need to apply the product rule. So I'm going to get the derivative of x times y squared plus x times the derivative with respect to x of y squared. Then I'm going to get plus the derivative of x cubed is 3x squared, and the derivative of y is y prime. Now the derivative of x is 1, so this is y squared plus x times the derivative of y squared is, you're going to apply the power rule like normal, so 2y, but then you're going to multiply by the derivative of y because y is a function of x, plus 3x squared plus y prime, and then this whole thing equals 0. So what I want to do now is I want to take this expression and I want to solve for y prime. And what that's going to involve is getting all the terms that do not contain a y prime factor on the right side of the equation. So this expression multiplies out to 2xy times y prime, and then I just have plus y prime, and that's going to equal negative 3x squared minus y squared. So then what I'm going to do is I'm going to factor out the y prime. So if I factor y prime out here on the left, I'm going to get y prime times 2xy plus 1, and that's going to equal negative 3x squared minus y squared. So then the thrilling conclusion here is that y prime equals negative 3x squared minus y squared over 2xy plus 1. Alright, so now in order to test that out, I'm going to look over here at some points on the graph. So this goes to the point 0,3, but it also goes to the point, let's see, does that go to the point? It looks like it goes to the point 1 comma 2. I mean 1 comma negative 2, of course, duh. Well, we can check that out. Okay, so if I do 1 times negative 2 squared plus 1 to the third plus negative 2, I do in fact get 3. So I plugged x equals 1 and y equals negative 2 into the equation up there. All right, so let's use that point. Okay, so at that point, at the point 1 comma negative 2, I get y prime is negative 3 times 1 squared minus negative 2 squared over 2 times 1 times negative 2 plus 1. And I am very lazy, so I'm just going to type that's negative 3 minus 4 all over negative 4 plus 1. So you get 2.333. So what that is 7/3. The numerator works out to negative 3 minus 4 over negative 4 plus 1. Well, that's 7/3. Right. So then if I use point slope form of a line, I get y equals m x minus x1 plus y1. That's 7/3 times x minus 1 minus 2. So if I go over here and I type 7/3 x minus 1 minus 2, there's your tangent line. And similarly, if I used the point 0, 3 to do the same thing, now at this point, you get y prime is -3 times 0 squared minus 3 squared over 2 times 0 times 3 plus 1. Well, that's just going to equal -9. So y is using this formula again. Y is -9 times x minus 0 plus 3, so -9x plus 3. And if I just type y equals -9x plus 3, there's your tangent line. And that's the basic idea of what this implicit differentiation is telling us.